Hi, I'm Dave, and this presentation is about test-driven development for Cobol. If that's what you were looking for, you have found it. Most of this will be a demonstration, but first let's level set. That's an IBM buzz phrase, and we're talking about IBM-related technology today. Let's start by asking why people thought Cobol was a dead language. Next, let's see if we can find a connection between Cobol and agile software development. That might be nice, given the theme of the conference. After that, let's understand why mainframe Cobol developers today are not using test-driven development, or indeed any of the software development practices we in the Agile community think of as baseline. There's a unit testing tool from IBM called ZUnit. Can Cobol developers use that for TDD? Cobol isn't familiar to most Agilists, as the Agile movement started after Cobol had already been declared dead. So I'll show you some code, and in particular I'll show you why familiar approaches to the unit testing problem don't quite work for that language. Okay, if familiar approaches don't work, then what does? Let's have a quick overview of the approach we use on the Cobol Check project. At last we get to the code. About time, eh? After the demo, we'll talk about where the Cobol Check project is going. Is it something you can use at work right now or recommend to client teams? Let's get the mandatory introductions out of the way. No, not like this. I started out on mainframes in the 1970s. Cobol wasn't my first language or my favorite, but it's the one I used the most on that platform. Like most people, by the late 1980s, I believed the mainframe was going away. So I got into other technologies and tried to learn whatever I could to stay employable. Java wasn't my first non-mainframe language, and it isn't my favorite, but it's the one I've used the most since 1996. I've still visited my old friends from the mainframe neighborhood on occasion, especially after getting into Agile coaching around 2004, as I learned Agile in the context of a large bank, and have worked mainly with large organizations since then. Cobol and other mainframe technologies have always been relevant in those environments. Recently, I've turned my attention back to the mainframe platform. I've learned it has not only failed to die, but has evolved considerably in the past 20 years or so. It's a pretty impressive piece of engineering. But I'll try to stick to the topic of this talk and not get carried away. In 2014, a group of coaches were facilitating a code dojo for a client. Another large bank, as it happens. We were doing a basic TDD exercise using Java. It was FizzBuzz. You can't get enough of FizzBuzz, right? Anyway, someone in the room asked whether it was possible to do TDD with Cobol, as that's the language they were working with at the bank. The other coaches replied, "It's impossible." I was young and impetuous in those days. Well, impetuous. Impossible was a trigger word for me. So I spent the weekend hacking up a crude unit testing framework for Cobol. At the next Code Dojo, we did FizzBuzz in Cobol. People enjoyed it, but I didn't think it would amount to anything, as I figured mainframes were going to be replaced by other systems any minute, and Cobol wasn't a language people were choosing for new development. It turned out a company in Europe discovered the project on GitHub. It was another large bank, by chance. Funny how that happens. But I wasn't paying attention to the project and I didn't notice their pull requests, so they forked it and kept on developing it. In 2020, the Open Mainframe project contacted me to see if I planned to do anything with that project. It turned out there was interest after all. I didn't want to move that project forward as the framework itself was written in Cobol, and Cobol isn't a good language for that sort of thing. So I started from scratch using Java. That's where we are now. We have a subset of the functionality of the original project rewritten in Java a little cleaner. And we have an actual team, with several people bringing different backgrounds and skill sets to the project, including the team at the European Bank. What does any of this have to do with Agile? Well, in the past few years, Agile transformation initiatives in large organizations started to include the mainframe platform. And that means Agilists have to understand that platform and the languages that run on it. It turns out that Cobol never died. It was just hiding. Hiding in plain sight, running most of the truly significant business data processing operations around the world, including about 80% of all financial transactions worldwide. You know how agilists are always going on about vertical slices of functionality? Well, if you deliver changes to the mobile app, the web front end, the presentation tier code, the tactical database, and the mid-tier application server code, but you don't deliver corresponding changes to the back-end code, the systems of record, and the enterprise database, have you actually delivered a vertical slice? After all, the cake goes all the way down to the plate. Cobol source code looks different from code in most languages we use today. Why does it look the way it does? In the 1950s, when Grace Hopper was developing the Flowmatic language, which would later be renamed Cobol, there were no job descriptions like software developer, tester, or analyst. In those days, the expectation was that people who needed software would write their own. Computer scientists developed programming languages to express solutions in a way that made sense for people who worked in a given domain. For instance, APL was designed to resemble mathematical notation for the convenience of people working in science and engineering disciplines. Similarly, Cobol was designed to express business data processing solutions in a way financial analysts and accountants could relate to. The structure of Cobol source code resembles the structure of a business document. Hopper was working in the U.S. Navy at the time, and a Cobol program is structured like a document that would have been very familiar to her team, a response to a request for proposal. The executive summary describes the purpose and scope of the proposal. The identification division describes the purpose and scope of the program. The environment division connects the internals of the program with things in the outside world, like files. It also declares information that is conceptually similar to assumptions in a business document, like the decimal point character. All variables used in the program are declared in the data division. Variables and executable statements are not mixed in the same part of the source file as is usual for most languages. This is where executable statements go. Of course, source statements are not executable, they have to be compiled, but you know what I mean. Executables produced by mainframe compilers and assemblers don't lend themselves to runtime manipulation. That makes it difficult to implement a testing framework that operates by modifying the object code. This has imposed a limitation on testing tools, like IBM's Z-Unit and tools from other vendors. The smallest unit of code that can be exercised in isolation is an entire executable. In the case of Cobol, especially batch Cobol, that could include quite a lot of functionality. The scope of unit tests that can be written with these tools is much larger than we in the Agile community would consider appropriate. Besides that, there is no practical way to stub or mock external dependencies. External dependencies have to be virtualized or simulated. That means a significant amount of setup work for any kind of executable tests. What we really want is to be able to exercise individual Cobol paragraphs in isolation. To achieve this, Cobol Check operates as a preprocessor. The preprocessor interprets test cases written in a testing DSL that resembles Cobol and makes a copy of the program to be tested, injecting test code into the copy. Then the copy is compiled using any Cobol compiler. The copy of the program containing the test code is executed, and the injected test code outputs the test results. This is not ideal on a philosophical level, as we are not testing the exact same copy of the program as will be deployed in production. But the approach of running a preprocessor is normal in the mainframe environment. It's the way special commands are inserted into Cobol programs to support CICS and DB2. A preprocessor converts those commands into standard Cobol call statements that invoke the appropriate system facilities. Cobol Check uses the same strategy to inject test code into the program under test. Let's see how the test DSL looks. This sample shows only a little of what's possible. When people familiar with Java, C#, Python, or similar languages look at this code, they invariably ask, why we didn't just copy something like JUnit or NUnit. The reason is it's designed to be intuitive to Cobol programmers. Cobol programmers are not familiar with JUnit, NUnit, RSpec, Jasmine, or any of that. If we copied one of those, it would be more difficult for Cobol programmers than this kind of syntax. The test case statement marks the beginning of a test case and supplies a name that will be output with the test results. Following the arrange, act, assert pattern, this Cobol statement is setting a value in the program's data division. This is a precondition of the test case, so it's the arrange step. The field named text value 1 must contain the value something in lowercase before we invoke the paragraph under test. For the act step, we perform the paragraph under test. This is how Cobol Check enables a single paragraph to be executed in isolation without running the whole program. And this is how an assertion looks. This is not Cobol syntax, it's part of the DSL, but it's designed to look intuitive to a Cobol programmer. Okay, let's see how we might test drive a solution to the FizzBuzz problem. What you're looking at is VS Code running on a Linux VM. We have GNU Cobol installed. We've been talking about mainframes the whole time, but we're not running this on a mainframe. Part of the idea of Cobol Check is to enable Cobol developers to enjoy the same sort of smooth and fast workflow we enjoy when working with other languages. That means removing the overhead of moving every little thing back and forth between the workstation and the mainframe. We also don't want the overhead of scheduling and running batch jobs to preprocess, compile, and run the tests. That would defeat the purpose of working in very fine-grained increments. So we download the code and work with it on our local system or on a cloud-hosted VM. When we're ready for integration testing or other kinds of testing at larger scope than unit testing, we can upload the code to the mainframe. I hope I made the font size large enough for this video. You can set up Cobol Check however you want. I have used the Maven convention here. So we have a source, below that main, below that a directory named for the language, in this case Cobol. We also have source, test Cobol. So, to test drive FizzBuzz, we need to create a file for a test suite. We'll put that under source test Cobol. The convention for Cobol Check is to have a directory under the test subdirectory with the same name as the program we're going to test. Now let's create a file for the test suite. Okay, we start with test suite. We'll call it FizzBuzz Challenge. And our first test case can verify that our program returns 1 when the input value is 1. You remember the FizzBuzz thing, right? For a list of integers from 1 to 100, the code returns fizz for integers evenly divisible by 3 and buzz for integers evenly divisible by 5. When the integer is evenly divisible by both 3 and 5, we want it to return FizzBuzz. There are more optional specifications that we sometimes introduce later, but we don't want to give away all our secrets at the beginning. So we need to write the arrange, act, and assert steps in this test case. Often it's easier to begin with the assertion and work our way backward. Let's do that. We expect to see a result of 1 for the input value 1. Cobol doesn't return values in the same way as Java and C# and so forth. It just populates a value in its own data division. So let's assume a field name for the result. How do we get to that result? We'll need an input value. Let's assume a field name of WS input. That's our arrange step. For the act step, we'll perform a paragraph that doesn't exist yet. Remember, we're test driving. Let's call it percolate. Okay, we have enough in place to give it a try. We know it will fail because the FizzBuzz program doesn't exist yet. Cobol Check is a standalone Java program. We'll run it from a command line. This cryptic error message means that Cobol Check can't find the source file for program FizzBuzz. Don't worry, improvements to the error messages are on our to-do list. As far as TDD is concerned, we're in the right place. We have a test case that is driving us to create the FizzBuzz program. We'll go up to the source main Cobol directory and create the FizzBuzz program there. The suffix CBL is recognized by the compiler we're using. We'll use the Camtasia extension for VS Code to speed up our typing. The percolate paragraph is empty. We expect our test case to fail because the FizzBuzz program does not produce the expected result, and not simply because the program doesn't exist. And there it is. The empty percolate paragraph doesn't populate the field WSResult. That's where we expect it to be at this point. According to general TDD practice, the next step is to add just enough code to make the test case pass. If we need more functionality beyond that, we must create the appropriate test cases to drive out that functionality. All we need to do to satisfy our first test case is to set the result to 1. Okay, we have our first passing test. Let's try an input value that yields a different result. We'll add a test case for the number 3 and drive out the logic to return fizz. This is good. The test case for the new logic fails for the right reason, and all the previous test cases still pass. All those numerous test cases. Let's add the logic to produce fizz when the input value is 3. To save time, we'll use the VS Code extension to copy and paste code. Those yellow squiggly lines indicate this is unreachable code. The program does a go back immediately at the start of the procedure division. At this point, the only way to run a paragraph is via the test runner. That's okay for now. But I'm going to disable the IBM Open Editor for Z extension so we won't see it complaining about unreachable code. All right, we have the functionality for the numbers 1 and 3. Let's try a 5 and see if we can produce buzz. And we have one failing test for the right reason, and all previous tests are still passing. It's time to add some code. This is what you call engineering. Yeah, we might want to refactor this later. At least we have some confidence that the program can handle a 3 and a 5, and it handles the number 1 correctly. A good start. While all our tests are passing, let's clean up the code a bit. There's duplication for the division. We can pull that out into a separate paragraph. Unfortunately, we have to do it manually because there's no useful refactoring support in editors for Cobol yet. But that's not an excuse not to refactor. Okay, we're still good after refactoring. But wait a minute. If the input is anything other than 3 or 5, the code produces 1 as the result. That's not right. Let's drive out functionality for other values. We'll try a 2 and see what happens. Yep, just as we suspected. In Cobol, returning an integer value as text isn't as simple as in many other languages. To save time, we'll use the whip extension to VS Code to insert code quickly. Okay, this is looking better. Let's see if we can get FizzBuzz for the number 15. We'll use some sleight of hand to type fast. Failing for the right reason. Good. Let's implement this as a Cobol table. In the interest of time, we'll just whip the code into place. Then we'll use the Magic Instant Refactoring in the interest of time extension for VS Code. It's amazing how many extensions there are, isn't it? One thing I find interesting about this is the amount of code necessary to implement FizzBuzz in Cobol. In many modern languages, you can implement FizzBuzz in a single line, including the part about traversing the list of input values. Cobol is the most verbose programming language I've ever seen. And yet, test-driven development is possible with a little effort. We aim to make it practical and useful as well as merely possible. Is Cobol Check ready for prime time? I would say no. But is it ready enough to try? Yes, definitely. That European bank I mentioned is using their own fork of the original project in their continuous integration process. Using that implementation, a test failure causes the pipeline to stop. They have invested in building out their own tools for CI and CD. We'd like to make Cobol Check a practical part of such a pipeline. You can find the project on GitHub, and you can add issues to request functionality or to report problems using the tool. There's a lot of documentation on the project wiki. If you want to see what functionality is available and what we're planning to address next, look at the user guide on the wiki. From there, go to Common Test Case Patterns. We've prefixed the titles with the release number we're targeting for each piece of functionality. If you'd like to see what the test code looks like or what we think it will look like for any of these use cases, follow the link from this page. We use the GitHub issues as a to-do list. You can visit the issues page to see what is in plan and to see issues that interested parties have added. There's a lot of discussion about future functionality, including integration with development tools. But there's a long way to go to get there. Filter the list by milestone to see what we're planning to do and when. Of course, all plans are tentative. You can add issues if you'd like to see any particular functionality, or if you run into problems using Cobol Check. In summary, there are a couple of good reasons to consider test-driven development in Cobol. The primary reason isn't related to Agile as such. It's IBM's mainframe modernization program that started in 2000. Among many other things, it involves modernizing the Cobol language and mainframe runtime environments to incorporate traditional assets with emerging technologies, including direct interop between Cobol and Java. Modernization of legacy Cobol applications will also mean breaking monolithic programs apart so that the relevant sections can be exposed through APIs. Changes like these would benefit greatly from TDD and from test automation generally. Second, as Agile penetrates the deep back-end systems of large enterprises, this is the time to bring leading-edge development practices to a platform and a culture where they have been missing for a long time. As far as challenges are concerned, the main challenge for supporting TDD in Cobol and other traditional mainframe languages is tooling. To date, companies that create tools for mainframe developers have conceived of unit testing as an after-the-fact type of testing and have not properly understood TDD. Their unit testing tools assume that developers will want to generate test cases automatically based on existing production code. To use these tools for test-first development is clumsy at best, and it's my observation that developers will stop using a technique if it is too inconvenient. Secondly, they have never considered testing at a finer level of granularity than a whole executable, probably because that has never been possible before. Now that IBM is embracing open source in a big way, we have an opportunity to introduce tooling that can support contemporary development practices like TDD. With that, I will thank you for watching and invite you to contact me with any questions or comments.